Good day, everyone. In this video, I am going to discuss to you the three laws of motion as presented by Sir Isaac Newton. Okay, so let's begin with the set of objectives in the discussion for the first law. So we have apply Newton's first law to obtain quantitative and qualitative conclusions about the contact and non-contact forces acting on a body in equilibrium. We also have differentiate the properties of static friction and kinetic friction. And then the last one, of course, is to solve problems using Newton's laws of motion in contexts such as but not limited to the ropes and pulleys. We also have the design of your mobile sculptures, transport of loads on conveyor belts, force needed to move stalled vehicles, determination of safe driving speeds on bank curved roads. Okay? So without further ado, let's start with the first law of motion. Our first law is also known as what we call law of inertia. Okay? If you take a look at the word inertia on your dictionaries or in the web, so you can see there the meaning, or it is actually being implied as the resistance to change, okay? Or not being able to comply with changes, meaning to say it opposes changes. So for the first law, we all know that it implies that an object that is at rest will continue to be at rest, and an object that is in motion will remain in motion unless acted upon by external forces. So meaning to say, without any disturbances or without any external forces in the equation, if an object is moving, it will continue moving for a lifetime. If an object is at rest, it will continue to be at rest for a lifetime as well. Okay? Or actually what we call forever, right? So in physics, we can imply it as for a long period of time. So in the symbols, we have here your summation of F, or the overall force applied or the force that is present in that specific scenario is equal to 0. Meaning to say, walang nadagdag, walang nabawas. Okay, that is how we imply what is the first law is all about. So we can recall on the first things or the introduction given to us by Sir Pot that we have this different set of forces that is acting on an object. So we have here your normal force, your friction force, your applied force. So the normal force is actually associated with the gravity, or your 9.8 times 10, 9.8 meter per second squared rather. So given these things, itong formula natin, we have your gravitational force, this one, is equal to mg, or your mass times the pull of the gravity, and your normal force is equal to the 9.8 meter per second squared, and then your friction force is equal to your F, or your applied force. It will be quite the same given that the object is in equilibrium state. Okay, meaning to say, it is, pag sinabi natin equilibrium, it is in the state of being equal. Okay, so walang nakakalamang na forces. So this set of formulas are true in the equilibrium state of an object. Okay, so we have your friction force. Pag sinabi nating friction, di ba, we can recall even during the elementary days, pinaka-example niyan is that when you try to rub your palms, di ba, pag nirub natin yung palms natin, anong nangyayari? We encounter heat, right? Kasi yan yung tinatawag natin actually na presence of friction. So for the friction, under this laws of motion, we have two types. That is what we call the static and your kinetic friction. So what is the difference of these two? So titignan natin, these terms naman are actually what? The static and kinetic are actually associated with different types of energy. So pag in-imply natin yung meaning niya, it's almost quite the same. Pag sinabi natin static, stationary, ibig sabihin this is the friction that keeps an object at rest. Okay? So the object is continuing or being continued to be at rest provided or because of the static friction. So to initiate the motion of the box of a man, given the example or in the figure on the right part of the slide, so in order to have a motion or para magkaroon ng change sa location ng object, we must overcome the total static friction of that object. Okay? So, ibig sabihin pala ma'am, we can therefore conclude that the heavier the objects or the wider the parang area or the surface that it actually parang covers, the more that we encounter the static friction. We can say that. Okay? Kasi meron naman tayong set of formula for solving this one. So talking about the static friction, So we have here, it is symbolized by small f, huwag malilito, kasi bigger F are for force, di ba? So small f that is, or that has a subscript of S, ibig sabihin this is your static friction is equal to your normal force, di ba? You can recall kanina that F sub N is your normal force times your mu that has a subscript of S, ibig sabihin this is the coefficient. Ibig sabihin this is the value of the friction that is present in that specific scenario. Pag sinabi naman natin kinetic, on the other hand, so kinetic energy that is associated with movement, right? So once the static friction is overcome, balikan natin itong example in this picture. So once this object is now being moved, or it happens that this person was able to pull this one, nag-create siya ng change sa distance, meaning to say that there is a force applied. So pag naigalaw na siya, technically, doon napapasok yung tinatawag nating kinetic friction. However, kinetic friction, from the meaning itself, is the one that, or the force that slows down a moving object. So although na-move natin siya, we can't specifically, di ba, tulad sa car, you cannot parang accelerate in a maximum rate after the car is at rest. Hindi pwedeng agad-agad mabilis, 'di ba? It somehow slows down, 'di ba? Medyo mabagal bago tuluyang bumilis. Pwede din naman na example na medyo mabagal bago tuluyang huminto. Okay, so that is how we are going to interpret what kinetic friction is. So an example for this one is this football player that is sliding, a baseball rather. So a baseball player will come to a complete stop. So at some point, hihinto talaga siya, dahan-dahan hanggang sa huminto siya, simply because of the presence of what we call kinetic friction. Okay? So even though the object or the subject is moving, it is being parang subjected with the kinetic friction itself. So either way, kahit na stationary or moving ang object, meron pa din siyang friction. Okay? So yun yung tatandaan natin for this one. So this is actually represented by this formula. So you have here your kinetic friction is equal to your normal force times the coefficient of your kinetic friction. Okay? So basically, multiplying lang naman ang may encounter natin for only if given na ang ating coefficient. Okay? So here is the thing when we talk about law of inertia. So, pag sinabi nating law of inertia, pwede nating i-associate yung experiences natin when we are trying to ride vehicles, say for example, bus. Di ba? Lalo na yung malalaking vehicles. So, sa bus, kapag yung bus natin suddenly nag-start, ano nangyayari sa katawan ng tao? Our body are what? Pushed backwards. Di ba? Pushed backwards yung katawan natin pag suddenly umandar, paabante, yung ating bus. Simply because dito na papasok yung sinasabi natin, an object at rest will continue at rest. Okay? So, hinahanap ng katawan natin yung dating point or yung reference point natin. Kasi nga, dapat kung walang other friction or walang other forces applied, magko-continue lang tayo na at rest. Kaya when the bus suddenly moves forward, our bodies are what? Being pushed backwards sa ating backrest. Okay? Another is that, kabaliktaran, when the bus suddenly stops, okay, pag suddenly huminto yung bus natin, what happens to our bodies are, we are being pushed forward, right? Pushed forward tayo kasi ang orientation ng katawan natin is that we are moving forward. Okay? Kaya doon papasok yung an object that is in motion will continue to be in motion unless acted upon by external forces. Another is that, pag lumiko ang bus sa kaliwa, ano ang implication ng body natin? Papunta tayo sa kanan. Kasi we are to follow the straight path. Okay, the straight path of movement. Kasi yun yung orientation natin when it comes to law of inertia. So because of this phenomena, so we have now the implications of headrests, airbags, and even your seatbelts. These are things created in the vehicles to keep us safe. Kasi nga natural na magkaroon tayo ng different set of movements na pag huminto, yung katawan natin papuntang harap, pag nag-move forward, yung katawan natin papuntang likod, pag pumunta sa kaliwa, our bodies are moving straight line, papunta sa kanan, and then vice versa. Okay, so that is now that explains the presence of these safety, parang tools inside the vehicles.